Hello, welcome back to chapter 48. So, we are in the middle of discussing how our neurons work, how they send signals. So, before we talk about how they are sending things, we're going to talk about how they are at rest. So, this video is mainly going to talk about resting potential. So, all cells have pores on their membrane, including neurons. Some of the different pores they have are shown in this image, and we are specifically going to be discussing ion channels. Ion channels are pores that allow ions to go in and out of the membrane. And because ions have charges to them, when they come in or out of a membrane, they affect the relative charge of the membrane inside and outside of the cell. In cells are typically going to have a more negative charge inside compared to outside. So there's more negative ions in the cell and more positive ions outside of the cell. This difference in concentration of ions, here if you look at the picture, you can see more potassium in than out. You can see more sodium out than in. This difference in concentration of things and also the difference in charge is called transmembrane potentials. And this gives a source of energy because the attraction of those opposite charges of the positive charge outside of the cell and the negative charge inside of the cell, they are attracted across that plasma membrane. For a resting neuron, the transmembrane potential is called resting potential when it's not sending a signal. The two major factors in creating the resting potential are sodium-potassium pump and potassium leak channels. The first of these, the sodium and potassium pump, is going to pump 3 sodium outside of the cell and pump 2 sodium in. So you have 3 positive charges going out, 2 positive charges going in. That means overall you've sent more positive out than in. So that's already starting to create this positive outside, negative inside. However, that's not a lot of difference. 1 ion overall. So this is starting it, but it's not completely going to be what controls it. So the sodium-potassium pump helps start this polar charge where the intracellular fluid, or ICF, will have a high potassium and low sodium and develop a negative charge, and the ECF, or the extracellular fluid, will have a high sodium and low potassium and overall develop a positive charge. The resting potential of a neuron is typically around negative 70 millivolts. That negative telling you it has more negative inside, and millivolts telling you how much that charge is. So, now that we've started to make this gradient, that sodium gradient is pretty stuck because there's not a lot of pores that allow a sodium to leak back into the cell. So you don't have a diffusion of sodium coming down its concentration gradient. However, there are potassium channels. Look at all these potassium channels here that are open. That's going to let potassium go down its concentration gradient, so it's going to leak back outside. Because there's more potassium in than out, potassium is overall going to keep going back out. So that is going to create more of a net flow of positive ions going out and contribute to a positive charge outside of the cell. There's not a lot of pores here that are permeable to negative ions, to anions, including chlorine ion. So we don't have a lot of negative charge. Really, it is the flow of sodium and potassium that are helping set up this transmembrane potential. Let's watch this video about resting potential from Bioflix.
Even without an action potential, the axon is a busy place with many ions moving across its membrane. Much of this ion movement is driven by the sodium-potassium pump. Using energy from ATP, sodium-potassium pumps actively transport sodium ions out of the cell and potassium ions in, creating an uneven distribution of charge across the membrane. Some potassium channels are open all the time, allowing potassium ions to leave the cell. As a result of these ion movements, the inside of the cell is negative relative to the outside. This condition is called the resting potential.
Then one more little clip I want to share with you. Oh, snap. Never mind. Okay. Well, I will. Oh, too bad. Sorry, I lost that video. But we will come back for the discussion of what happens to an activated neuron, how we end up with an acting potential in our next video. I'll see you in a little bit. Bye.